everybody for joining us. This is going to be a conversation more than a traditional panel. There'll be no slides, but we hope we'll be able to share a lot of insights and things to make you think after this panel and going forward. First, I want to ask each of my colleagues here to give a quick 30-second or less intro of themselves as it relates to the topic of AI and cloud. So, Ferris.
Hi, my name is Ferris, like Bueller. I was actually named after him. Ask me about that later. I'm CEO and co-founder of Surge.ai. We figure out what's trending across the entire internet for anything in real time, so you can do market research literally in real time. We are a small startup that runs a large industrial scale search engine that makes 1.5 trillion requests a day. And we build search engines for companies. I used to work at LinkedIn, where I got to implement MapReduce and Hadoop personally with no cloud. So I understand how far we've come, and I'm so happy to be here today to talk to you about this.
Numa. Hi, thanks for having me. So I'm Numa Dhamani. I'm a principal machine learning engineer at Kung Fu AI. We are an engineering firm and AI consultancy that's focused exclusively on artificial intelligence. So we work with our clients we use all sorts of cloud providers, so everything from AWS, Azure, GCP to some of the more smaller ones.
Luke.
Dr. Luke Wilson. I'm the chief data scientist at Visius, an Austin-based consulting company focused on advanced computing technologies like high-performance computing, AI, and all of its various forms in quantum computing.
Luke and I are the co-senior partners in Visius, so I've known Luke a long time. We also work on the Austin Forum together. Numa has been a frequent participant and speaker in the Austin Forum, and so I'm very lucky to have known her for the last couple of years. And Ferris, I met through the Austin Forum just recently through our Slack workspace and realized that would be a really good mix of people that I've known a long time, a short time, and just met to give perspectives on the topics today. So I'm going to jump right into it. The topic here is AI and cloud. Great relationship, but needs work. So I went through many topic titles like that, and I wanted to make sure we talked about the pros and the cons. And the first one is really a softball question. I'm going to argue that as much as, including when I teach AI, we say, oh, it's data and algorithms and GPUs have fueled the AI boom. I'm going to say that really an accelerant for this was cloud computing, and probably deserves, especially in the last few years, almost a fourth leg of the chair credit for that. So I'm going to ask each of you for your opinions on that. How important do you think the cloud computing model has been in the explosion of AI capabilities and adoption? I'll start with you, Ferris.
Sure. Immensely important. I think it's represented a step-level change in AI adoption in particular. Having quality models available through third-party cloud APIs where all your other infrastructure lives is so much better for deployment, adoption, and tuning than it's ever been. You previously needed to have so much experience with deployment, having everything work with your own workloads and balancing that accordingly, and then tuning and evaluating the output and iterating accordingly. We're now teams with absolutely no experience or expertise in-house on machine learning, on data science, on AI, can launch and build and deploy products with AI. So I think it's been absolutely massive, a step-level change.
What can you add to that, Numa?
Yeah, I would agree with that. I think cloud has helped facilitate the adoption of AI, but then at the same time, AI has helped facilitate the adoption of cloud. I think what cloud has done is it's a lower upfront cost. It's more flexible. You don't need as much expertise. And instead of spending so much money building on-prem solutions with really complicated architectures and design, you can really quickly go do that and test it out and see if it works for you or not.
Luke?
Yeah, I think it's all interconnected, right? So I think there's two things here. The cloud enabled kind of the modern AI revolution because of access to infrastructure. There's plenty of compute access, there's plenty of GPUs and whatnot to build some of these models in the first place. But I think in terms of adoption, it's not really about the infrastructure of the cloud, it's about these additional services, these pre-made models that you can access in the cloud. Because enterprise and consumer customers that are trying to build AI today aren't starting from scratch. They aren't starting from a raw Jupyter notebook and understanding TensorFlow. They're starting with something that already exists, and they want to fine-tune it. They want to make something, tweak something a little bit. So having all of these libraries of models existing in the cloud, I think, is really what's creating this rapid acceleration of adoption.
So you've all sort of given great answers to the first softball question. The second and final softball question is, name one of the advantages in the cloud that you think has really spurred AI in addition to the presence of software hosted in these environments and the availability of infrastructure. What's something else that you would attribute to cloud as fueling the AI explosion? Maybe something that people don't normally think about. Numa, we'll start with you on this.
Can I repeat what I just said?
Nope, it's got to be something new.
I think what's really nice about it is, so we have a lot of clients that we work with who have never worked with AI before. This is the first year they're getting their AI budgets, and what we're able to do now is they can actually kind of go in, pick like something like Amazon Bedrock, and test out a whole bunch of different APIs, and without having a lot of expertise to do a lot of this in the first place, and be able to start to identify use cases. And I think there's a lot they can do for themselves without even us going there for just like internal productivity, or just being more efficient, which is something that wasn't necessarily possible for them like 2, 5, 10 years back.
Luke.
Yeah, I agree, Numa. It's, for our customers, it's really this, 5 years ago, if someone wanted to do a proof of concept, they wanted to come to us and talk about doing something in machine learning. I said, well, do you even have a data set? We're going to have to build something from scratch. Before you see something that we can even think of as a minimally viable product, you're talking 6 to 12 months. Sorry. Now it's like, all right, well, let's just start with something that already exists. We can use, Amazon Bedrock. You can use something like Vertex AI in GCP or something like that, and you can get going in a couple of days or weeks. And they can see something that they can turn into real value for their company, as opposed to waiting months on end for something that's remotely viable.
Yeah, we actually do proof of concepts in like 6 weeks now. That previously would have taken us 6 months.
And I think just to hit on that a little bit, something that's easy to forget, we're talking about barriers to entry. The vast majority of companies and dev teams don't have machine learning expertise, and now they can build with AI. That is such a substantial opening of barriers to building, deploying, productizing, testing, and iterating, and doing it much, much, much faster. And then separately, if you do have in-house expertise for AI, ML, data science, you actually now can deploy that, pun completely intended, towards more in-depth R&D and differentiators for your business, instead of just doing the basics. Which we've all been a part of.
Yeah, and I want to emphasize this point of speed. I've been in the supercomputing game and high performance for a long time, and we have these arguments about on-prem versus cloud and the economics of each, and people can make different points of arguments depending on circumstances, like variable versus sustained workloads and such. But it's really the speed thing that I think has helped in the AI era, because we're seeing tens of thousands of software companies come out of nowhere in this. It takes time to design a data center. It takes time to build a data center. It takes time to issue an RFP and design a new solution. It takes time to deploy that solution in a data center. It takes time to break that solution in. And then after that year or two is up, your developers can start doing such. Or they can run a credit card in a cloud model, and it might be more expensive on a per cycle basis, but the time is money. And that, to me, in the era of rapid explosion of AI, has been probably the greatest advantage to startups for using the cloud, at least. And then to the cloud providers, the tremendous aggregation of data that they get from whatever they're hosting on it.
Yeah, I think if you look at it in another way, ChatGPT came out, what are we now at, 15 months ago? In less time than it would take you to permit the building for a data center, we have an entire industry of software companies based on these generative AI foundational models that is worth tens of billions of dollars. It did not exist 15 months ago. And we wouldn't even be pouring the first concrete on a data center if we were building it.
Luke cheated ahead on my next question, because I was going to ask, as useful as cloud computing has been in accelerating AI, is there really any debate about it enabling the generative AI era? I mean, all of these generative AI models that are really being used by hundreds of millions of people, they're all provided by cloud providers, right?
No doubt. I mean, it's purely an accessibility thing. We're almost certainly already using cloud, and if you aren't and you want to get into applying AI, you're thinking about cloud, especially if you want to scale and deploy software that will actually go to end users. So,
I agree. I think the cloud has made accessibility huge for AI. And what has happened with Gen AI is, even if a lot of these companies and organizations aren't necessarily using Gen AI, now everyone's really excited about AI, right? Like, AI is in the news, there's buzzwords, everyone's super excited. And like, we have clients come to us all the time who are like, we want to do Gen AI because everyone's talking about Gen AI. And we're like, cool, I think you actually don't need Gen AI. Maybe, you need a different kind of AI. But let's talk about that. But now it's like on people's radars, right? And it wasn't before. So I think that has been huge for AI.
Yeah, I think two things there. One is the cloud-provided generative AI models that anyone could access within seconds, just signing up. And I really think that on the Gen AI side, it combines with natural language processing. I mean, a lot of people don't know how to use a computer, but everybody knows how to speak or write, or both. And the fact that you could type something in or say something in, and suddenly it was communicating with you like a human instead of a computer, and now accessible from everywhere, of course, that helped Gen AI blow up. And then all those other advantages of cloud for startups in this space help them catch up and develop new things. How many apps are in the OpenAI ChatGPT store now? Isn't it hundreds of apps already in there?
560, I think.
560 apps already for, as Luke said, something that's 15 months old. Yeah.
I just want to hit on what you said, which I think is really important. The whole prompt response model and doing it in natural language wasn't just important for mass consumer adoption, but I also think that's important for development. I'm jumping ahead here a little bit, but I think this is one of the big game-changing elements for adoption, was that ML APIs, even in cloud, have always been a little bit esoteric and required some training and practice to implement and tune, where the prompt response model is so straightforward to implement and get going that even someone who's just learning how to build products can start to interact with it and integrate that into their workflows, into their apps, and to start thinking about it, because it's human intuitive. There's a dark side to this too, which we can come back to later, but I think that the idea that you can intuitively implement AI via the prompt response model was really game-changing for adoption.
So I'm going to change gears just a little bit from the pre-ordered list of questions that we talked about in the speaker's room, and I'm going to insert one here, and that is, cloud has completely enabled the training of these Gen AI models, or at least facilitated them. Do you see much near-term hope for small language models and for people to be training more of these foundational models, but at smaller scales on-prem in the near future?
I love small language models. And I think that we are starting to see a lot of that already, with just distillation and them being more specialized models. And I think there is a need for more smaller specialized models, especially for when you have really like customized tasks that don't necessarily, work well with a generalized foundational model that you'd have to fine tune, you'd have to prompt. So we're starting to see a lot of that. A lot of the smaller ones do have comparable results to some of the bigger ones on certain tasks. And I think we're only going to start seeing more of that just because of the amount of compute, resources, time, and just the lack of specialized knowledge.
Yeah, I think this is really the trend. We've seen over the last, 4 or 5 years this growth in kind of general purpose, natural language, large language models But they're getting towards the end of their useful scalability. We're getting into the trillions of parameters with these very large models. They don't run anywhere except in the cloud. And for a lot of real tasks that you actually want to perform to do something useful, they're not very good. And so going to specialized small language, narrow domain models that are focused on one or two tasks of specialization, I think is the only way to move forward, especially given the way we do things in the cloud. I mean, this is the cloud model, right? We moved from monolithic architectures to microservices architectures. We're doing the same thing with AI. A large language model is a monolith. And the cloud model is really to turn that into microservices, into small, narrow domain agents, and then push those out into the cloud to work with each other.
I really like that analogy.
What's that?
Oh, I just said I really like the analogy.
Yeah.
+1.
All right. So would it be fair to say then that as important as the cloud model has been for accelerating the growth in development and adoption of AI, and perhaps as an enabler of Gen AI, that we might see a shift back more to on-prem resources as people begin to adopt small language models and other techniques that are maybe not as dependent on massive training infrastructure? And don't answer edge yet, because that's my next question.
I think it is. I think you see a mixture of things. I think there's still space for the large language models, the general purpose models, but there's a lot more space for the small domain models. And so you're going to have this mixture where you're probably putting a lot of domain models in your own infrastructure because they contain the majority of your value, right? As a company, those are going to contain all of your trade secrets. Those are going to contain all of the net value to your company. And then the large language models sit in the cloud, and you call them remotely for doing kind of the coarse processing tasks that happen above that. And so you're going to see this mixture where you're repatriating your data, you're repatriating your models, especially these small, narrow domain models, back into your own infrastructure.
Yeah, I agree. I think it's going to be a lot of hybrid. So we do a lot of government work, and one of their really big concerns is these really large language models that have certain legal issues, privacy issues, security issues, and they would really like to run stuff on-prem. So we talk a lot about how they could do some smaller language models to run on-prem and utilize the larger foundational models for more like general tasks. I also think that so I agree, I think for a lot of organizations or companies that do have very specialized needs or tasks in terms of requirements in terms of security or privacy or specialized tasks that can't be accomplished with the general model, you will start to see a trend in that direction. But then I also do see a space for the large language models on cloud for a lot of the LLM developers that are trying to do things like agentized models and are trying to have these LLM assistants. And I do think there is space for them both. And I think you can still have on-prem and you can have cloud. And I think what we're going to start seeing is more hybrid.
Yeah, and I completely agree with all of that. Particularly, it's just all the same arguments for on-prem anything. One other task that one other context that I want to dive into that you mentioned that's really important here is specialized models. When we're getting into the realm of models that are designed to do very specialized tasks, all of a sudden quality and output and evaluation becomes significantly more important. So in the same vein with the arguments for on-prem, you want to be able to dissect to whatever extent you can with black box models to understand how to iterate and understand where you can start driving it towards the correct results, because they may matter. Precision recall argument all over again may become increasingly costly for them to be wrong or do things the wrong way.
So now I want to tackle the edge computing question. We saw it in the roadmap that Civo showed here in the presentation, either right before or right after lunch. And we've all seen the market and analyst reports that say training is where all the infrastructure revenue is right now, but inferencing is where it's going to go. Do you believe that most inferencing is going to move to the edge and most of this AI spend is going to occur at the edge, as many of these reports say? Or do you think that the increased connectivity we get to these devices is going to enable the inferencing to stay in high throughput clouds and data centers, and the edge devices maybe be dependent on even less for computational reasons, just for communications purpose, sensing and communications?
I think we're going to see a hybrid of both. So when you have cloud, you have limitless compute. It's really easy to scale, and I think we're still going to see that, right? But it comes at a trade-off of latency. It comes at a trade-off of security. It comes at a trade-off of privacy. And I think for certain specialized tasks where latency is absolutely important, when you have something where privacy or security is absolutely important, I think you will start seeing maybe like a hybrid of both. It could be where you have, let's say you have like a model that needs to be updated on like real-time data, and it could potentially use, the cloud for periodic like updates to the data, but then to make the predictions that might be on edge. So I think we're going to start seeing a lot of those workflows, and I think that's kind of where this is headed, where we can not have to worry about latency, but still kind of get all of the power that you would get from cloud compute.
Yeah, I think, first off, I think edge is an overloaded term. There are a lot of different edges in this space, and there are some edges that are outside the data center. There are things that have to be done, at extremely low latency that involve some sort of physical connection. Like an autonomous car, or a robot in a warehouse or something like that. But then there's a lot of inferencing that happens at the edge of the data center. It's wherever the user comes in to make a web request. It's not an API access necessarily, but it's someone processing a web page doing something online. And so, you might spread that out over, in a content network or something where you're trying to reduce latency for your web accesses. So it's still sort of an edge. And so we really have to think about what edge means and understand that there's going to be different types of edges for different types of applications.
I couldn't agree more, and I honestly don't think it'll be very different than online learning, which is something we've gone through this whole cycle with already with a lot of technologies, with a lot of the same considerations. So I completely agree that it'll probably be a hybrid approach, and it'll be very use case specific, and it'll be more portfolio, depending on what sort of product and use case and problem that you focus on at the time.
All right, one of the big issues facing society in our lives is climate change and sustainability. And we all know data centers and cloud data centers have been around for almost 2 decades at large scale and have significant power consumption issues. But just as we've seen this explosion in training these AI models, we've seen an explosion in the demand for very power-hungry chips like the NVIDIA H100 and such. And so computing is really getting in the crosshairs of the people worried about climate change and sustainability, who are concerned about training ever larger models on hundreds of billions of parameters and such. Then, of course, we saw the news about, Sam Altman wanting $7 trillion for chip making, which he didn't mean it all in 1 year. People keep comparing it to the US total budget for 1 year. But even spread over time, that's a tremendous amount of power for all of those chips. And a lot of it's being driven by AI. Training now, potentially inferencing in the more shifting towards inferencing in the future. What are your thoughts on this? How can we address this insatiable thirst for AI capabilities while promoting more sustainability, less carbon impact, and so on?
Let's train small language models. I think when you do that, you naturally mitigate a lot of these sustainability issues, right? You also mitigate a lot of issues with bias in data because you're probably going to carefully curate your data. So you'll mitigate also issues with privacy there. You'll mitigate issues with copyright. So now I'm getting into a whole lot of issues that you didn't ask me about. So back to climate change, I do think it is a really big problem with data centers. So as of now, it is data centers actually leave a higher carbon footprint than the airline industry. So, and it's also, I think, a single data center uses as much electricity as more than 50,000 households. And in the U.S. combined, like collectively, the data centers use more electricity than like small nation states. So we use a lot of resources on data centers, and it does leave a really significant carbon footprint.
So I think it's an interesting problem. We can always talk about things like, oh, well, if we were training smaller models, they would be more carbon efficient because we wouldn't need as much compute and all that. The problem is that it doesn't matter how large the model is we're training at this point. It doesn't matter if it's big compute or small compute. The total aggregate amount of compute we need is going to continue to grow. It could be that, you know, in the future, we're not training as many models. We've trained all the models we need to train. AI is perfect and complete. We don't have to do anything else. And we're just doing nothing but inferencing. The problem is we're going to need 1,000 times more compute than we have now just to do all the inferencing we want to do. And so I don't know that from kind of an AI model perspective, there's a lot we can do on the data center climate change side. We do need to figure out a way to power these data centers in a more responsible way. We do need to figure out how to build chips that are more energy efficient. But that's a physics problem at the very end of the day.
I think what also is really lacking right now is we don't actually have very concrete numbers for how much energy it takes to train a lot of these models or for inference. A lot of the companies don't actually release a lot of this data. So I think that would be a step in the right direction.
Well, we're starting to get that data. Oak Ridge National Lab trained a large AI model on a publicly funded supercomputer and shared I don't remember the number.
It's limited though.
But the amount of power. But one thing I want to throw in here that I agree with more efficient algorithms, because even though we'll need more compute, the more efficient the algorithm is, the better. I agree with more efficient chips. But one of the things I wanted to throw in, because we're in Texas, we have something like 16 or 17 gigawatts of wind power, of excess wind power in general in West Texas. So often you'll drive through West Texas and you'll see the wind turbines in fields, some of them off. And I used to always think they were broken. It turns out they weren't broken. It's stranded power because of the difficulty of getting it from West Texas to East Texas. So one of the things I would love to see is these large training data centers move to green power sources. And you could even move it to wind, because if you say, well, the wind's not always blowing, it's like, do you really need to train that model and finish training it today, or could you wait until tomorrow? Training AI models is not a real-time dependent thing like operating an emergency broadcast system. So I'd love to see, and we're starting to see it now. There's a data center in Canada that begins with a Q scale that advertises being able to host 200 kilowatt racks for HPC and AI, 100% sustainable power from hydro all the time. That's impressive. I wish we would start building them in places with hydro and wind and solar, and use carbon as little as possible for the things that don't require real time.
Yeah, I think there's a big opportunity for improving the efficiency of the input power. I love, I'm a big proponent of putting the compute where the power is. So moving data centers like to West Texas where all these wind turbines are. If only we had cooler weather like in the UK so that we could shed the heat load into people's houses and pools. No one wants spare heat here in Texas.
No spare heat in our pools here in Texas. They get hot enough in the summer.
That's right.
Ferris, any thoughts on this issue of the impact of growing AI demands on training models and the climate impact?
I'm just a big proponent of increased efficiency with both the models and inferencing. And I think the application of super efficient learning processes and inference processes are still in their early days. I think if you want to keep in touch with the research, that's one thing to do it, but paying attention to what Meta open sources, particularly as far as increasingly more efficient models, will kind of give you a preview into where we're going with that. And as far as the use cases and their impact on energy efficiency, I think it's a bit early to think it through too far, but I'm excited to see where that goes.
Yeah, and I'm excited to see that today we're, at this conference, we're talking about very today and tomorrow things. But I've heard at least 2 speakers today remind us that everything we're doing today and tomorrow in large language models is clearly way off optimal, because that little piece of gray matter sitting on the tops of our necks is, 13 watts, not 20 megawatts like the Oak Ridge supercomputer, but just 13 watts, and does many things more amazingly than that. So that just speaks to how much room we have to increase power efficiency in what we're doing. So I'm going to move on to the next question now, and this one is really about the challenges. So what do you see as the top current challenges for new AI developers, startups, et cetera, in using cloud computing? We talked about how AI and cloud have a great relationship, but always needs work. There was a great talk before this one, by the way, about some of these challenges, but I wanted to hear from each of you about what you see as a top challenge for startups in using cloud computing for AI.
Sure. So this one's near and dear to my heart because it's what I spend most of my nights working on. Quality control. Most large-scale AI models are essentially black boxes at this point. And it's very, very hard to tune quality of input-output, especially because it's so easy to work with them. And the whole prompt response model is so easy to implement. It becomes very difficult to build boundaries on what sorts of input, what sorts of output, what might come back, what may not come back. And companies like OpenAI in particular are moving so fast with their models that you can have week-by-week variances. The models are being updated and changing the responses and the type of the responses and the variance in the responses quicker than you can implement quality control. And I think we have a whole new category as far as adoption for companies like startups. I'm doing a startup where we're at the Series A stage. I speak to a lot of seed and pre-seed companies, and everyone has this challenge where they want to implement it, they're implementing it, they're making it happen, but they can't control experiences with users and output as easily, and it's just a huge challenge. And I also think it's an opportunity for cloud providers to start providing more tooling around this. Maybe it's a lot more offline instead of online, but I'm very excited to see how we develop our approach to implementation and controlling quality. But
so I think the biggest barrier to entry for people getting into the space right now is the speed of change. I mean, you can make a decision to start learning about something on Monday and it can be obsolete next Monday. So while the cloud has enabled rapid change and rapid growth and evolution in the space, it also makes it harder to, it's harder to catch a moving train than it is to board when it's standing still. And so being able to figure out how to make that point easier, and maybe it means that we need an AI to synthesize all the changes that are going on in AI on a weekly basis so that people can understand what's happening. You can have that one for free, by the way. I think without some way of simplifying the onboarding process, it's going to be very hard. And that's not to say impossible. I'm not saying don't do it. Start learning about it. Get on board with the process. But it does move very quickly now.
Mine's a little adjacent to that, which is just user education. So I think that with the advances with cloud and AI, there's a lot of people who want to do this right now. A lot of people who maybe don't necessarily have the expertise to do this. But we are in a space where it can still be really hard to navigate, cloud. Like, it's really hard to actually build really efficient distributed systems on cloud. It's even if you're leveraging the APIs, there aren't very clear disclaimers about their limitations or capabilities. You maybe don't even know where your data lives, what kind of transparency controls there are, which is a little bit of a barrier of entry for some of them, right? And then it's also, I think there is increased concern with, well, I am either really intimidated because I need to move from Azure to AWS and now it's completely different and I don't know how to do this. Or it's like, okay, I've been using Azure all my life, this is excellent, I love it so much, but none of my architectures are scalable. I don't know how to use autoscaling. I don't know how to really make distributed architectures. So I think more user education on that front would go a really long way.
Yeah, I couldn't agree more. We talk about how they make it much easier to do things than having to learn how to build a data center, design a solution, bid it out, deploy the system on-prem, learn how to use it, et cetera. But that doesn't mean on an absolute scale they're easy. It just means that it's easier than the alternative. They can still be quite challenging to use, and we still don't have ChatGPT create a fully functional and deploy a fully functional web service that will auto scale up and down and blah, 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 and work across all of the clouds, always leveraging the one with the cheapest resources at that time, et cetera. And it would be hard to do because you'd have to retrain the model as fast as the changes are happening. So yeah, that's a tough challenge.
I'll create it, it just won't be efficient.
All right, so I want to ask each of you for a top recommendation for a cloud computing provider, for software developers that could augment or improve cloud computing for AI, or for an AI developer themselves. So a cloud computing company, a software developer to make cloud computing easier, or an AI developer. And I'll let you go in any order and pick one of those categories.
I'll just continue from my previous one. And I spend so much time looking at user policies and data privacy policies and security policies to be able to tell our clients, I would really, really love some transparency there. Just easier to navigate. I would love some transparency and controls and just easier to understand where this data is, where it's going to go. Is it, complying to the different states and countries? And that would make my job easier.
I think on the cloud provider side, I think we've kind of created an ecosystem that's a double-edged sword. We have this huge ecosystem of companies and products in the cloud native foundation that provide all sorts of services and all sorts of capabilities. The problem is we have this enormous zoo of tools and companies that provide all these services and all these capabilities, and it's impossible to figure out exactly how to use all of them together or whether or not you should. And so I think, one thing that would make cloud adoption a lot easier, and this goes for both kind of the managed services at kind of the cloud service provider level and all the fundamental software services that are provided kind of at the cloud native computing foundation level, having a better way of organizing all of this, or creating more best practices around it, or quick starts or something, some way to help people get started more easily than just giving them a pile of service names and saying, well, go read the documentation, hope you can figure it out.
I couldn't agree more on that, like dead, simple, ease of use and user experiences. We know it works at this point. The whole explosion of Gen AI is due exactly to that. I think for, coming back to the question, both cloud service providers and developers for them, I'm just going to harp on what I was getting at earlier. Quality control and transparency and explainability is going to be huge. We're building products. We want to build products with cloud and with AI in cloud, and we're moving very fast in doing so. But things break also. Things aren't, the variability in what you're getting and what you're doing is really hard to control for, and it's hard to have consistent value in lines of business if you can't really explain and understand how things are being generated, how responses are coming through, the efficiency of them, the cost of them, and when and if how that'll change. So I think just giving us some basic guidelines like we've always had with essentially everything in cloud up to this point, for being able to control for what we're going to get would be beautiful. For AI developers in particular, this is kind of wild, but can we go beyond the transformer? There's so many questions and thoughts, and I could harp on this all day, but I think the next generation of AI will be going beyond the transformer. And I can't wait to see what we'll be able to do once we have more of that available.
All right, I had one killer question about how they see the world of infrastructure for AI in cloud in 5 and in 10 years, but we have 1 minute and 40 seconds left, so I'm going to ask you to ask them that during the break, and instead I'm going to ask you the softball question that we threw out, but we have enough time for now, which is, what one movie or book really do you enjoy about AI? Could be fiction as well.
Oh, my favorite AI movie has to be and will always be War Games. I think that is the quintessential AI movie. It boils down all of the concerns into one kind of perfect 97-minute, talk.
I love her. I actually did an Austin Forum panel talking about her. It's one of my favorites.
Ghost in the Shell. I think the idea that man versus machine versus what will they look like when they start to become the same thing and we integrate both together, and what those lines will look like is a fascinating question philosophically and soon to be practically.
I agree. All three of those answers are great, and I would throw Ex Machina in there, but I'm with Numa that I'd probably, of all those, because of the current generative AI era, I would encourage you to go watch the movie Her again. It's now 11 years old, but Spike Jonze hit a home run on that, and when you watch it now, you'll see, oh, that's like Siri Smart Assistant. And then halfway through the movie, you're like, oh, that's a voice-activated LLM. And then by the end of the movie, it's something else. So it's really interesting to watch that movie and then talk about it with friends. And I appreciated Numa being one of my experts. When I did a showing of it, I had AI experts instead of film experts talk about what was feasible and not feasible in that. So I want to thank the panelists very much. Please give them a round of applause.